Hello and welcome back to Dr. Logic Awkwardly Does Logic. In this video, I'm going to give you a model and an interpretation and a very simple sentence, and we're going to go through the truth conditions introduced in the previous video and figure out, is this formula true or false on that model with that variable assignment. So it's just a toy little example. It's not going to be particularly interesting or have any kind of, deep meaning behind it. It's just a chance for us to see how the definitions work. So our language is going to consist in one constant C and one binary relation R. So that's our language. Our domain is going to be a set that contains two objects, and we're just going to label them 1 and 2. And then we need to say what the constant and the relation mean on this model. So the interpretation of C I'm going to define to be 2. And then the interpretation of R is going to be the set of following pairs: 1, 1, 1, 2, and 2, 1. So it's important to remember that when I put things in angle brackets, this means that the items within them are ordered. So this is why I have both 1, 2 and 2, 1. These are not the same pairs. So I could have made this interpretation anything I wanted. This is what I wanted it to be. And then we need to have a variable assignment. So let's the variable assigned to x, the value 1. The variable assignment will assign to y 2. And then for any other variable, we'll just let it be arbitrary. It's not going to matter because those other variables aren't going to turn up in the sentence that we are looking at. So the question is for every x, there is a y if rxy, then, if for every x there is a y, rxy, then for every x, rxc. So you can read this sentence as saying, well, if everything is related to something, then everything is related to C. So that is the formula in question. And then we want to know, is it the case that this is true on this model containing this domain and this interpretation and this variable assignment? What we can do is we can kind of work through the definition of truth from the complex formula all the way down to the most simple. So what we know is that a conditional is true in a model with some variable assignment if and only if either the antecedent is false, so it's not the case that for all x there is a y, rxy, or the consequent is true for all x, rxc. So we've got two cases that we need to consider. Let's actually consider this case first, just because it's a simpler formula. And if we can make that one true, then we're good to go and we don't need to look any further. So consider case 2. We know that the formula for all x, rxc is true on this model and variable assignment if and only if for every x variant v prime, we know that on the same model, but with the new variable assignment, rxc is true. Now this is going to be the case if and only if we have, so all of the possible things that could be assigned to x Well, we've got two things in our domain, so we know that either 1 and the interpretation of C needs to be in the interpretation of R. Oops, I need another angle bracket there. Did I say either? I meant both, because we need this to be the case for every possible value that X could have. So we need it to be the case for 1, and we need it to be the case for 2. So that the pair consisting of 2 and whatever C gets interpreted for has to be in the interpretation of R. And this is going to be the case if and only if we take, well, what is the interpretation of C? The interpretation of C is 2. So that is the same as saying that the pair 1, 2 is in the interpretation of R, and the pair 2, 2 is in the interpretation of R. This is what it means for every object in our domain to be related to whatever C picks out. C picks out 2, so that means we need to have that the pair 1, 2 is in the interpretation of R, and it is. So let's get a different color. Tick for that. That's not a different color. That's a different color. And then we need to have that 2, 2 is in the interpretation of R. But it's not. So fail. It's not the case that both of these things are true because one of them is false. So that means this is false. That means this is false. And so that means this one is also false. So I'm going to have to erase this now in order to have enough space to consider the other case. But we need at least one of these to be true. And we know it's not the second one. So now let's go and see, is the first one. So erasing is always so time consuming on the Zoom whiteboard, but there we have it. So now let's consider the first case. So consider case 1. Now here, we're not looking at truth, we're looking at failure to be true. So we will be using the same definition, but if truth is true if and only if this, then not true will hold if and only if not this. So we just go through our definitions and make sure everything is properly negated. So on a model with the valuation V, for all x exists y, Rxy is false if and only if its negation is true. So, yep, that's the same as saying not for all x exists y, Rxy. So we've just used the truth conditions for negation. Now, as you'll remember from our previous video that we showed, that you can always take a negation and move it to the other side of a quantifier and change the quantifier. Similarly, going from this way, this is going to be equivalent to there is an x such that for all y, not Rxy. And now we are in a case where we can use the truth definition for the existential statement. So this is going to be the case if and only if there is an x variant V prime such that on the model with this new variable assignment, for all y, not Rxy is true. And that is going to be the case if and only if, for every y variant of this x variant V prime, we have V double prime. We know that on that new variation, not Rxy is true. So what we are looking for is we are looking for some object in the domain that is not related to anything else. So the reason we have such a small domain is we want to be able to look at all of the possible cases. So let us consider the case where V prime assigns to X value 1. So then what we need to do is look at all of the possible values for Y. So we consider the case of 1, 1 and 1, 2. And are neither of these in the interpretation of R? No. In fact, both of them are. So this doesn't hold for that particular X variant where X gets assigned to 1. So what happens if actually we consider the one where it is assigned to 2? Then we need to look at every possible value that Y could take in, and then see, is it the case that not R, 2, and then that value holds? So we've got to consider the cases of 2, 1, and 2, 2. And is it the case that every single one of these is, again, not in the interpretation of R? Well, this one isn't. 2, 2 is not in our interpretation, but 2, 1 is. So this also turns out to be false. So this is false, this is false, this is false, this is false, which means that, in fact, for all x exists y, r x y is true on this model and this variable assignment. We've already shown that this is false, which means that the answer to our question is for all x exists y, r x y implies for all x r x c true on this model in this variable assignment. The answer is no, because in fact the antecedent of the conditional was true, but the consequent was false. Now, interestingly, and I'll leave this as a exercise for the viewer, if the interpretation of C is changed so that instead of being 1, it is 2, then this sentence is true in kind of this augmented model, let's call it M prime, on that variable assignment. So you can work through all of the cases yourself to prove that this is true. At this point, working through variable assignments and making sure you're checking all of the possible combinations may seem like a combinatorial nightmare. We'll do some more examples so that hopefully you start becoming more comfortable with seeing what are the things that you need to check, how do you assure that you are checking all of the possible kinds that you want. You will very quickly come to love the existential quantifier when you're trying to make things true. You will very quickly come to love the universal quantifier when you're trying to make things false. But we'll go through a couple more examples. Don't worry until after we've done them. Before you don't start getting worried or concerned until after we've done a bunch of examples. If you're still not understanding it, then try to work through some examples on your own. Ask me questions if you've got any questions. But hopefully after a few more examples, things will be somewhat more clear. So join me next time. It will be somewhat more interesting than numbers. We will talk about dragons and unicorns instead. So take care. See you then. Cheers.